So here's our paper 2, guys. Okay, so T break over. Relative frequency means an experimental probability. We've not done probability, that's year 11, but it's basic. We want 13 out of 50, and with a calculator that comes to 0.26. Okay, so 13 out of 50 is 26 out of 100, 0.26. Question 2, rearranging. Take the 2 over and divide each little bit by 2. And so the gradient of the line is not going to be 3, it's going to be 3 over 2, otherwise known as 1.5, all right? Remember, you've got to get straight lines in the form of y equals something x plus c, all right? Well, yeah, c. Let's get that out of the way, because the c is actually 2.5, not 5. Let's call it c. Okay, all right, so, yeah, you've got to get it from that into that form. So divide through by 2, and there's your answer. 3 over 2, 1.5, that's the gradient. Expand this and simplify. Well, that's me multiplying out, so you can study that in your own time. 2x times 3x is 6x squared, etc. If you multiply correctly, you should end up with 10x minus 12x is minus 2x. It wants the middle part, okay? Which part of the answer? So that belongs to that. You won't get a minus 21x anywhere. You don't see minus 22x anywhere. The only thing you will see is minus 2x if you work it out properly. Okay, so if a number is rounded to 3SF as follows, how big can it go? It can go as big as 6.375, but it's not allowed to actually be it, so hence we're looking for something less than 6.375 in the upper bound. And the lower bound is going to be 6.365. So this is the correct answer. All right, that's the lower bound, and that's the upper bound. But please note, x has got to be less than that. So 6.4 and lots and lots and lots and lots and lots and lots of 9s. But for calculation purposes, we'd use that. Now that's the end of the grade 4 questions. Question 5 I know is grade 5 because simultaneous equations are grade 5. So that's the easy questions done. But this isn't difficult either. How do you solve a simultaneous equation? Well, because it's identical to the one in the foundation paper, we can see we can eliminate the 2y's by subtraction. Hence, 7x take away 3x is 4x, 36 take away 16 is 20, x is 5. Substitute the 5 into perhaps the bottom equation because it's simple. So 15 plus 2y equals 16. I could put a 15 there. Subtract. Yes, sorry, 16. So 16 take away 15 gives me the 1. So I really want not to have that there because it's going to destroy that step. So what I've done, of course, is multiply 15, take it over and subtract, get 1. 1 divided by 2 is a half, y is a half. All right, there's the 2 answers right there. Tom's building a wall. He wants to, obviously, that's his livelihood. It's the first problem-solving question that we've got involving a real-life situation. Again, this can't ever be taught. You just need to practice them when you stumble across them and do them. So large packs of tiles cost 18 quid for 40. Small packs cost 14 quid, so it's cheaper, but only get 28. Now here's the good thing. You get a 25% reduction if you buy 3 or more of the large ones. So I reckon that's going to come into play. So I've got to get over 100 tiles at least. So I went for 2 of these plus 1 of those. All right. So 40, 40, 28 takes me to 108 tiles. It's a good trial, but I need something to start my thinking on. So 50 quid, okay, not bad. Then I'm going to try 3 lots of the large tiles, which gives me 120 tiles. I don't need the 20 tiles. I'd say at least 100. So 54 is not very cheap compared to the other one, but I do get 25% off. How do you get 25% off that? You multiply by 75% in one step. 0.75. That gives me £40.50, which is way cheaper than 50 tiles. Way cheaper than 50 quid, and I've got some spare tiles for the next job. £40.50 is cheaper. Yeah, this is an extension to the problem. There's an awful lot of calculations that Tom has done. He's basically got it right. He went the length of the floor 600, and each tile being a lovely square is just divided by 40. So that he wants 15 tiles to fill the length of the floor, and with the width 240 over 40, he wants 6 tiles to fill the width of the floor. And what did the donut do? He added 15 and 6 to make 21 tiles. That's never going to work. 2 rows of 15, we're up to 30 tiles. And here's the question. Give a reason why Tom's method is wrong. It should be 15 times 6, Tom. You need 90 tiles, all right? 15 times 6. And many of you wrote a whole story here, which I didn't want to read. I just want to see a simple 1-mark statement. It should be 15 times 6. Okay, getting a bit more tricky now. We're clearly into grade 5/6 already, because it's getting complex. Journey is in 2 stages. Stage 1, that many miles in 2 hours. Stage 2, same speed as stage 1. What does that say to me? Work out the speed. Distance over time, 55 miles per hour on average. I've got to work out the time for stage 2, and I've got the distance. So time equals distance over speed, which is 44 over 55 miles per hour, which is 0.8 hours. All right? If that's in miles per hour, and that's in miles, then the final answer's got to be in hours. Change it into minutes. Well, multiply the number of minutes by 60, 48 minutes. Done. This is algebraic equivalences, so we're probably on grade 6 right now as we speak. I've got an identity. I've got to work out A and B. This is what I call mix and match. Multiply this out. So this is identical to that, which means 3ax is identical to 21x's. A must be 7, all right? Because 21 divided by 3 is 7. What am I left with? I am left with minus 10a exactly matches the position of 2b. So say so. So minus 10 times 7, because I've got it in terms of a here, minus 10 times 7 is minus 70, is 2b, divide by 2, b's worth minus 35. Again, that was generally well done. This appears to be a probability problem, but it really isn't. It's really a fraction of an amount type problem. So I felt no reason why I shouldn't include this in the end of your exam, because you've all done fractions of an amount. Choir. This many people in total, I just felt that was going to be useful. The chance of picking a bloke is 2/5 if he wears glasses. The ladies, 3/8. How many people in the choir wear glasses? Okay, so it's 2/5 of 35, which can be done without a calculator easily. 40. 3/5 times 48 for the ladies, 18. Altogether 32. 3 marks. Finally, a bit of probability. What's the chance or probability that the person does not wear glasses? Well, if 32 wear glasses, the other 51 don't wear glasses, because that's the leftovers from the 83 people. What's the chance of getting someone who does not wear glasses? 51 out of 83. Pie charts. At the higher level, you will never be asked to draw a pie chart. You will be asked to analyse one if they set it. So this wasn't really a pie chart question. This was an analysing pie chart question. And for that, you just need mathematical knowledge and skill. You don't need a protractor or compasses. Let's read the story. This is called proportional reasoning. There are 450 more women than men. So, okay. Right, so the children must come to 260 degrees because kids are involved as well. So 260 degrees adds up to 360, and there's 450 more women than men. That means the 30 degrees difference between the men and women must relate to the 450 actual difference. So here it is. Now we can work out something. 30 degrees is 450 people in total. 1 degree is 15 people. So 260 degrees, I knew this would come in handy for the children. So 260 degrees times 15 people, 3,900 children. What were these guys doing? Oh, they're in a theme park. Okay, not during lockdown, you don't. Anyway, that's how many kids we got. Rearrange that. Okay, so I took my 2 over and plussed it. I get no marks for that. Then I've got to divide by 3. If I put a ring around the right one, I get my mark. Integers. Don't like this. First job is take away 3 from each end. That will give me this. inequality. Is that all right? Now I've got to pick all the values that satisfy this inequality and that inequality. So let's have a look. I can't drop below -1. So even though this will allow me to go as far as -2 and -3, I can't have it because I've got to fulfill both criteria. So I can start with -1. That fits, coming out to equal to -1 according to that. I can have 0. That fits between these two limits. I can have 1. That fits within these two limits. I can have 2. That fits within these two limits, and also just about fits within this limit. This says x can be less than or equal to 2. So therefore my answers are 0, -1, 0, 1 and 2, because that just about permits me to have that integer. And there they are down there. I think I overdid for 2 marks anyway. Joe and Kyle share some money in the ratio of 7 to n. Joe gets 35% of the money. Okay, work out n. Well, if the 7 parts represents 35%, then 1 part must be 5%, and so the remaining 65% must go to Kyle, and therefore I think it's going to be 1 times 13 parts to make 65, because, sorry, 5% times 30 makes 65%, which is the leftovers, so therefore the missing number n is 13. I told you I probably overdid it for 2 marks, but n is 13. So 7 to 13 is like having 35% to 65%. That's what I'm trying to say. Next. Challenging little question. Still on 6s, I'd say. Again, a very real life situation. This is Molly doing a 40-hour week, 35 hours at her basic rate of pay. If she does an extra, does more hours after hours because the boss needs to do that, then she's going to get paid more for those 5 hours compared to any of those 5 hours in the normal working week. So we're basically working out 2 different gradients as a rate of pay. And if you got this right, well done. So I don't know if you can see mine. I sort of drew a red line down there. So I want to work out the gradient for the normal working week. And I think that was 280 quid if you read across there, divided by 35 hours, comes to exactly £8 for every hour worked. Now, at the higher rate, as you can see, it's clearly a higher rate because the gradient is greater than the gradients of the normal working week. From 35 to 40, we've got 5 hours, clearly so. It does say that she worked 5 hours. And I've got to work out this little height here. I made that, I can't remember, 70. So there we go. So it's £70 worth of extra earnings over 5 hours. Well, that's like being paid £14 an hour. Work out the difference between the higher rate and the lower rate of pay. Answer £6 per hour more if she does that overtime, all right? Just by subtraction. Next. This is hard. They gave you a blank grid, Now, it's hard. So they've given us the equation of a line, and they want us to work out the equation of another line. A lot of this goes into the thinking. Now, this has got a gradient of 1 and an intercept of -1. So I know that number right there is -1. I didn't write it in, should have done, I'm going to do it now. So that number right there is -1. And if that's 0, that's got to be 1, and that's got to be 2, and that's got to be 3, and that's got to be 4. Yeah, 5 little squares, 1 unit. So straight away I know the intercept for line L is going to be +3. Is that okay? Straight away. Now I've got to work out his gradient. Well, I can't, because I don't know what the scale is along the bottom. Apparently for this line, the gradient is 1, because it says y equals 1x minus 1. So, wait a minute. 5 squares divided by 10 squares is not 1. It isn't, isn't it? So there's something wrong here somewhere. Which means, in order to get an answer of 1, this number here has got to be 1. Because 1 difference in y divided by 1 difference in x gives me a gradient of 1. Sorry, there's far too many 1s there. But anyway, what I've got is, I've got 1, 2, 3. So here we've got 10 little squares worth 1. Here we've got 5 little squares worth 1. That's difficult to get your head around. But clearly, to get a gradient of 1, I mean, getting the intercept of -1 was easy. You can just see where it crosses. But here, you've got to work out what the scale is. And here it's going to be 10 little squares is worth 1. It's got to be, because 1 divided by 1 has got to be worth 1 to get the gradient of 1. Too many ones again. So now I've got scales, which I can read off. Now I can work out the gradient of line L. Well, that's going to be 3 divided by 2, or rather, -3/2. It's a negative gradient. So the intercept is 0, 3, as I talked about before, and the gradient can be -3/2 or -1.5. Put the two ingredients of the cake together. Y equals mx plus c. Y equals -1.5x plus 3. This was difficult. Getting your head around all those. Again, this is problem solving. Even though you're applying standard mathematical techniques, there's an awful lot of mathematics to have to do. It's your problem solving. So, Kim, she's earning. We don't know how much she's earning, but I know she's paying this much in tax. Don't know how much she earns yet. I worked out that 20% on this amount of money is 7,500. I did. I used my calculator. Which means if she's paying tax at this level, and yet she pays even more tax than that, it means she must be earning more than 37,500. And the question is, how much? Well, if I take away her total tax bill, and that little part there for the excess at 20%, then at the highest rate of tax, she must be taxed 40% at 1,760. As you can see, I forgot to put the 0 there, so apologies to Mr. Botha and everyone else in the other class. There should be a 0 there. So taking away these two numbers, she'll be charged 1,760. So she'll be charged 40% on her extra 1,760. And what I should have done really, instead of going into this, I should have done this. So 40% of x is 1,760. When you divide by 0.4, you will get £4,400. So she earns, let's take a look. She earns this much plus the 37,500 because she gets taxed on that amount, plus the 12,500 right at the bottom for which she does not pay any tax, because that's the minimum wage you can earn without paying tax. She's going to earn that plus that plus that. This girl earns 54,400. Okay, so I need to sort of find out what job she's doing and go and do the same. So that's that. You should think about that. I certainly had to think about it. This is really easy, and it's so easy that many of you got it wrong because you couldn't bear the answer that you got. So, building company, labourers, joiners, electricians, plumbers. How many ways are there of choosing 4 workers, 1 from each, to get the job done? Choice of 2 times a choice of 14 times a choice of 9 times a choice of 8. And I did say times. You don't add, makes no sense. I have got 2,016 ways of taking one of each of these 4 guys, these different 4 categories of required worker. So there it is, 2016. In the next part, they're going off work. I'm going to lose a labourer, I'm going to lose 2 plumbers. So we're down to 1 labourer and we're down to 6 plumbers. But it's the same calculation. 11496, all multiplied. There's now only 756 ways of getting the job done. All right, 4 marks, not difficult. For those of you who are good at upper and lower bounds, you better pay attention, because on this occasion you were not good. The temptation is to stick that number right there and to stick that number right there. That's very naughty. Because if you look very carefully, this number is correct to 1 decimal place. This number is corrected at 1 decimal place, which means each of these 2 numbers have an upper and lower bound. So before I even answer the question, I'm going to write down my lower bounds and my upper bounds for each. 1 dp, that. 0.825 to round to 1 dp. This one, 68.35, okay? 1dp accuracy. Same with this one, 865, 875. Now you have to think. Work out the lower bound for M. And what many of you did, you just put these numbers in straight and completely ignored that, and then you rounded down your M to as low as you can possibly do it. No, completely wrong, no marks. To get M as low as possible, think of it mathematically, P must be as small as possible, and B must be as big as possible. So you're taking smallest possible and biggest possible way. And of course dividing by 2 just gives you a final answer. So I want the smallest possible p-value, that one, take away 2 lots of the biggest possible b value. Put it into your machine, you will get that, okay? And don't bother rounding off, just don't do that. Yeah, don't, leave it like that. Okay, a lovely easy function question. I suppose they're going to call this grade 9, but it's nowhere near the back of the book, so it's very easy. It's just substitution into a function. Jenny says f of 10 must be 2 lots of f of 5 because, anyway, she's completely terrible at maths. It's only 2 marks anyway, so let's get them. Is she right? And you've got to answer the question. Don't just stick numbers everywhere and just expect the examiner to answer it for you. Don't do that. You've got to work out f of 10. That means you shove a 10 where the x is, which is what I did. And that comes to that. All right? Put the 10 where the x is. And then you put the 5 where the x is and get that. And don't forget to times it by 2. Because she's reasoning that 2 lots of f of 5 is the same as 1 lot of f of 10. I understand that reasoning, but it's not reasonable. So then you say, well, 126 is not 216, therefore no. You've got to say no somewhere. You've got to answer the question, is she correct? Yes or no? The answer is no, for all the above reasons. This was easy, and obviously while I was having my tea break, I wanted to show you why these are the correct answers. These have already been factorized, so I've got to find the roots. In other words, where the graph crosses the x-axis and y equals 0. There it is. That's the reason. That's the reason. Okay. I'm not going to read that just yet, but I will show you this. Show that Katie can form this equation. That means show that Katie can make this equation from the above story. It doesn't mean solve it and try and work out x. It does not say that. Okay, it's only 3 marks. So let's see what I've got. I'm not going to read that, it's too much. You can read it. I've got a rectangle by the look of it. Is it a rectangle? I've no idea. It's a piece of cardboard. Yeah, it is a rectangle. Of course, it's different size dimensions. So the area of the entire bit of card will be x plus 5 times x. Cool? So that's that times that. And these are square cuts. And that'll be a 10 by 10. That'll be a 10 by 10. 10 by 10. 10 by 10. So I'm going to cut them out and throw them away. So, like I tell you in class, yeah, verbalize. Speak what you see. I see x times x plus 5 take away 4 lots of 100, yeah? That's what I see. I've got 100 for that, 100 for that, etc. And that's what I'm going to do. I got the area of the entire bit of card, take away 4 lots of 100. And this comes to 1,000. Where did I get 1,000 from? Answer, the area of the entire net, all this white stuff here, is 1,000 centimetre squares. Doesn't look much like that, does it? Mind you, multiply out. 4 times 100 minus 400 equals 1,000. Now bring the 1,000 over to the left side and subtract. Landed. Alright, 3 marks. Yeah, this is non-calculator work actually, although it's on a calculator paper. I've got to prove that the sum of 2 consecutive triangular numbers is always a square number. In other words, u plus u, let's make a square number. Well, thankfully the denominator is the same, so just put them all on top, multiply out really carefully, That's the n squared plus n bit, that's done. Here I've got n squared, 2n, 1n plus 2, that's that. Simplify the numerator. Divide, don't forget to divide by 2, of course. That gives me this. Don't stop there and say, here, that's a square number. Nope. Factorize it, that's a square number. It's a perfect square because it's n plus 1 multiplied by n plus 1. All right? Here we go, more ratios, at least grade 7. Yeah, grade 7. Ratios at this level are really confusing. I've got bottles of different sizes and glasses of different sizes. And they want to know finally how many large glasses can be filled with a large bottle. I've no idea. Let's look at it. Right, I don't seem to have the volume of juice in a little bottle, so I'm now going to have to work that out. So let's get on with it. Oh, so here it is. A small bottle is 2/5 of a big bottle. Where am I getting that from? Here. So 2 lots of small and 5 lots of big. So the volume of the small one is 2/5 of that whole big one. So that comes to 450. Many of you got that right. That's worth a mark. And then it says a small bottle fills 6 small glasses with nothing left over, not a drop. Oh, okay, so I could work out the volume of a small glass. 450, small bottle, divided by 6. Every small glass is 75 millilitres. I think I'm worth 2 marks now. What's next? How many large glasses? Oh, I better work out the volume of a large glass, which means I better use this ratio here. So large glass compared to a small glass must be 7/4, yeah? 7/4. I'm trying to draw with the mouse like I do in class. There we go, 7/4. So I'm going to take my 75 millilitres, my little glass, and multiply by 7 divided by 4, which is 131.25 millilitres for a big glass of juice or whatever. How many large glasses can be filled by a large bottle? Well, I know the volume of the large bottle. I finally get to use it. There it is. So if I divide 1125 by that, I will get 8.571 ... etc. etc. Let's read the question again. How many large glasses can be filled? I can't fill 9 glasses. I've just run out of juice, all right? So I can fill 8 large glasses, is that all right? Don't round it up. I know you see a number there. maths, whole number of glasses, a discrete amount. Yeah, but you've got to round it down to fill up 8 full glasses. Moving on. I love this question. Of course, I got it completely wrong right at the end, but anyway, I saw the error of my ways. I've got to square this thing. Now with a calculator, I don't know. I don't know why it's a calculator question, but it shouldn't be. I did it without a machine. So first write 2 of these side by side. 5√3 times 5√3 is 25√9. 5√3 times minus root 12 is 5 lots of minus root 36. And then we go again. Minus 5 root 36, and minus root 12 times minus root 12 is plus the square root of 144. Let's simplify. Well, we got 25 root 9, which is 25 times 3, square root of 36 is 6, etc., etc. Square root of 144 is 12. So that comes to 75. That comes to 30. That comes to 30. I've still got my 12. So I have got 75, take away 30, take away 30, plus 12 comes to 27. I have proven that this is an integer, that is to say, a whole number. It's not 25, it's 27. I need another cup of tea. I'm drying up. Oh, great, more of these things. All right. It's tricky because you've got to make use of the fact that that only has one solution. Only got one solution, which means if you imagine a graph like so, and there's the graph of x squared plus something x plus something equals nothing, that x value is 5 right there, okay? It exactly fits this scenario, which means there's only one root or one solution. So guess what? The equation is going to look like this. It's a perfect square. It's x minus 5 times x minus 5. There's only one solution. If you multiply this out, gives x squared minus 10x plus 25. So the B exactly matches the minus 10, and the C exactly corresponds to the 25. 2 marks. I think it's worth more. Right, this was definitely towards the back end of one of the exam papers I selected the questions from. Now, express y, x as a fraction of y. In other words, x divided by y is like saying a quarter divided by 2/3. Now, there's my quarter, there's my divided by 2/3. When you divide fractions, you invert, you find the reciprocal, so to speak, and you go a quarter times 3/2, and that gives me 3/8. And there's your answer. It works. Again, an awful lot of work for 1 mark. I wish they gave us lots of lines to try and get some marks for at least setting this up or that. This should be a 2 marker. But that's the answer for that. What's next? This is really hard. Many of you made so many brave attempts, and I hated not giving you marks for it. Alright, this is a speed time graph, and this is awkward because this is in kilometers per hour, and this is in minutes, in other words, not hours. So we've got to work out the area of each section. I did it in 3 parts. I went triangle, rectangle, trapezium. Fair enough? That's what I did. So triangle, rectangle, trapezium. So I did 3 little things. And I converted my time in minutes into time in hours. But it is a calculator paper, so I didn't worry too much. Now 5 minutes is going to be 5/60ths of an hour, or a 12th. I don't mind how you do it. So what have I got here? Yeah, what is that? I haven't got a clue. Let's start. So the first bit is easy. Half base times height. And there's the base, there's the height. There's half base times height, and the base is 5/60ths, because it's 5 out of 60 to make an hour. You know, get with a calculator. I'm not going to bother worrying about simplifying all the rest of it. I'll let Casio do it. This next part's easy. It's 102 times 40 minutes, which is going to be 40 out of 60, which is 2/3 of an hour, times 102. I ain't going to worry about that. And this is the trapezium that looks troublesome. This height is 102, this height is 96, and they really helped us with that. And this width across there is 15. So 15 out of 60, quarter of an hour. There's my A, there's my B, or call that the A, call that the B. It's half AB times H. Half A plus B times the height. And of course the height is on the side there, and that's 15/60. So I'm changing minutes into hours. Put that into your machine carefully, or if you want to, work out the 3 bits if you're not feeling secure about all those brackets. If you do it carefully and properly, you get exactly 97 kilometers covered, which means if I subtract, I've got 33 kilometers yet to do. Now, the reason I found it quite hard to give marks here is because I saw an awful lot of jumbled maths, and I couldn't tell what you were thinking. What of it was rough work? What of it was work you wanted me to actually? It's really hard to mark. So there it is. And again, even I ran out of space there because I didn't see how far it was going. But there we go. 97. If I saw a 97, you know, there's your 3 marks straight, which means you got all this right. And I gave many of you a mark for saying minus. So if you made this 96, if I saw a minus there, I went tick, correct method. Yes, well done. You get at least a mark for that, because that's essential. Right, what's this? Iteration. Now, I saw one exam paper that had 2 whole rows of answers. You don't need that. You do not need to overdo it. We're told that the first value to start off with is 2. We need to pump it into our Casio and keep pressing equals, equals, equal. Don't keep pressing millions of equals. It's like I showed you in class. You show all these steps and you show your answers because it's 3 marks, and then you've got to justify 3 DP. Now, I've got Casio ready for the occasion. So hope you can see that. So remember, 2 is my answer. Let's see if it works. Yep, it works. 2's in the memory. So here I go. I want the cube root button. Shift cube root of 3 times my answer. Remember the recurring x is the answer that we want to keep changing. Then we're going to add 7. All right? So on the cube root of 3 times the answer plus 7. Bam. There's my second value. 3, 5, 1, 3. I didn't overdo it because I want an answer to 3 decimal places. So I made sure I had about 5 or 4 on the boil. So can I justify it? Can I justify the answer to be 2.351? No, I can't. That's just my first trial. Hit it again. There it is. 4132. Yeah, 41323. 2.413. No, I can't justify it because nothing like each other. Keep going. It's getting closer. 42382. Yeah, 4238. I didn't bother with the 2. 3 decimal places. 2.413. 2.424 because the 8 will bump it up, but they're not the same, so I can't justify an answer yet. 2.4256. That is 2.424. That is 2.426. It's not the same, so I can't justify it yet. Hit it. 2.4259. 2.4259. Let's take a look. If I round this off, I would get 2.426. If I round this off, I would get 2.426. Yeah, I've landed. Don't do any more than 6 trials. Simple reason, by the 6th trial, you're not getting any closer to an answer that only requires 3DP, all right? So these are both rounded to 3DP, therefore it's not going to change or get any better. Bam, that's the answer that goes at the bottom of the page. Got it? What's it doing up there? What's next? Beautiful grade 9 question. I was so pleased. Many of you got this completely correct. I was very happy. Let's look at it. Not too complicated. So I've got 2 statements. F of x being 2x minus 3 and g of x being defined as x squared. I've got to prove that the inverse function of f, when you substitute 55 in, is identical to the same value as 4 of g of x, 4 of g of f. Or sorry, f of g of 4. I'm reading it the wrong way, sorry, because I know I've got to do the 4 first. That's the 4 and the g first. That's what I was thinking. So I've got to show this, which means I better work out the inverse function of this bit first. Like I showed you, we let y equal this, then rearrange it, and we get y plus 3 over 2 in one step. So the inverse function of x is going to be x plus 3 over 2. Now I'm going to use it. I'm going to put 55 right in there. 55 right in there. That gives me 58 over 2, which is 29. I'm up to 2 marks. Now I've got to create another composite, a composite function, f of g of x. In other words, you take the g function and you plant it right there in the f function. All right. So my new f of g of x is going to be 2x squared minus 3. I'm going to write that down and get a mark. There I did it. 2x squared minus 3. Then I'm going to shove in the 4 where the x is, because it wants me to work out f of g of 4. So put a 4 in. Pick up your Casio if you have to. I didn't. That comes to 29, and you've proven they're the same. That's the end of the questions, guys. I will now upload this to YouTube as well, and I'll send all of you the links. But before I do that, let me show you the grade boundaries. Let me show you the grade boundaries. Right. These are the grade boundaries for 2017. The reason I chose these is because these are the kindest boundaries that exist out there. In 2017, it was the first time that this course, this exam, went live. And they were testing the ground in terms of what's a grade 7 worth, where should we draw the line for grade 6, and this is what it was. So if you just about got into grade 7, you will never get an easy grade 7 again in your life. If you just about crept into grade 6, I promise you, you will never get such an easy grade 6 again. So you need to work and keep working. These are the boundaries. So you can judge for yourself, now that I've given you back your papers, how good was my grade 7? How good was my grade 8? How secure was my grade 5? You can just judge it for yourself. How good was my grade 4 pass? Yeah, so you can see how far you are from the next grade up, or whether you're happy with your grade. You need to maintain it, because in 2018 and 2019 those boundaries went up and up and up. Now, I've noticed for the past few years, and the paper's only been running for a few years, that a grade 4 pass is 20%. So that's not changed. Everything else has been bumped up a tiny bit. So, for example, in 2019, you need to get 85% to get a grade 9, which is plenty. Was it 86 even? Anyway, that's enough. Can't remember the others. Yes, I think the grade 7 was 57% in 2019. So you've got some work to do. So decide how secure your grade is based upon this, and then bear in mind future boundaries will be higher than this by a little bit. All right, so let's just call that off because we are done. Save changes now. What's the point? Just stop the video, shall we?